Heather.
So first of all, thank you so much for joining me today. I'm sorry I'm keeping you from food and drinks. I hope this is worth it. Given the talks we just had, I'm hoping in this talk to provide a bit of structure to the discussion of the relationship between science and politics, and in particular, why it is that you might have an automatic conception that science and politics in opposition, and why we shouldn't think that way about the relationship between science and politics, even if politics can pose a problem for the practice of science. Okay, so the problem that we have in front of us as scientists and as philosophers and as academics is this concern about politicization of science. There's a wonderful podcast by Nature that came out a couple years ago. The opening remark is, you stick to the science. Why are you being so political, Nature? You should just be about the science. A lot of those scientists want to be more active in politics, including having marches for science. And some people think that's a good thing. And then other people think that any discussion, including global warming alarmists, is a politicization of science. In general, in the background, there's this presumption that the more you get to advocacy and the more you involve normative judgments, the further you move away from science. And this gets to the problem of the relationship between politics and science and advocacy and science. So what should be the relationship between science and politics? What is the politicization of science? How should we define that, as opposed to just a knee-jerk reaction of, I don't like it when politics and science mix in some way? This gets us to questions about the social responsibilities of scientists and whether or not social responsibility itself can politicize science. And finally, to the question of whether or not advocacy is inherently in tension with science. I'm going to argue in this talk the answer to that one is no, but we have to get there first. So what I'm going to do in the talk is first talk about the social contract for science, which is where we get these naive conceptions of how science and politics should, or in the case of the social contract, should not interact. I'm going to talk about some problems with the social contract and why most people who look at this carefully think the 20th century social contract for science is dead and we need a new one. Then I'm going to talk about the challenge of politicization, how politicization can be a threat and how to define it. I'm going to define it in terms of overriding norms that are internal to the space of inquiry. I'm going to talk about what those norms are and show how replacing the norms for the space of inquiry with norms from politics, particularly democratic politics, creates politicization. Then I'm going to talk about how this understanding of what politicization is has implications for the practice of scientists as activists, as advocates, as trusted science communicators, and then we'll draw some conclusions. Okay, so let's start with the social contract for science, the naive view that many of us come to this conversation with. So after the end of World War II, predominantly this view came into being, and it would be a longer talk if I went into all the details of how it came about, but it was composed primarily of three interlocking concepts. The first was a distinction between basic and applied research that had different norms around each kind. Basic had some norms and applied had different norms. In particular, if you were doing basic research, you were freed from certain responsibilities, particularly societal responsibilities. And if you were doing basic research, that actually was the research that needed public funding in particular, because industry wasn't going to pursue that kind of research that was too far away from application. So part of the social contract for science is this linear model of funding, where we have the green public funds over here on the far left going into the realm of basic and pure science. Once they go in, the public isn't supposed to decide what research is done with those public funds. That's supposed to be done by scientists working within the space of basic research all by themselves. And so it's supposed to be value-free and independent of society. That research spits out particular effects and new knowledge that then gets applied very often by industry. This is where all the value-laden decisions occur about like how to apply science. And out of that, we'll get consumer goods, medical breakthroughs, and military security. With the social contract for science came particular ideas about what constituted scientific freedom. Scientific freedom was centered in basic research and included things like freedom from state interference or meddling in which projects should be pursued within basic science or pure science, freedom to decide what is worth pursuing solely in terms of scientific potential, like what methodologies you had, what were interesting theoretical problems. These were decisions to be made by researchers internal to a discipline, and there was supposed to be no external pressures or planning on that. And perhaps most importantly for my purposes in this talk today, freedom from societal responsibility, as articulated in Percy Bridgman's famous 1947 essay, Scientists and Social Responsibility, where he argued that scientists should not have to think about the societal implications of their research and be responsible for those implications. If they were doing basic research, they were in fact not supposed to think about that. And only those who were doing the applied research further downstream were supposed to be societally responsible for their research. And so you end up with this image of science as this circle outside of the messiness of colorful society, the basic research publicly funded but value-free and totally independent, aside from the funds, that then pumps into the messiness of society, applied science and societal use, and independent science advice in terms of facts. Now, in the 21st century, it turns out a lot of these underlying conceptions of the social contract have come under huge strain. So some of those problems are core ontological problems. For example, is there actually a cogent distinction between basic and applied research? If you think about applied research is trying to solve societal problems and basic research is trying to understand the world, well, where would climate modeling actually be? Because it's both trying to discover things about the world and trying to address practical problems. Or the research at PIC, it's probably both. And so when you look at examples of actual research, sometimes it's quite difficult to figure out whether or not it's basic versus applied. Even if you have some sense of what might be basic versus applied, there's a question about the ordering. Does basic research always come before applied research? And a lot of historians and sociologists of science have discovered that when you look at the details of scientific discovery, it turns out that this actually isn't actually what usually happens. Applied research is often something that needs to be used to inform basic research or is wholly independent of basic research and happens in its own space of discovery. So these things, the whole sort of general conception of basic then applied doesn't seem to actually be an accurate description of scientific discovery in most cases. Occasionally it does happen, but there are most cases it doesn't. And then there's the further deeper ontological question of whether science is actually outside of or independent of society at all. It's not, right? Like scientists don't operate in some hermetically sealed sphere outside of society that is just supported by funds from society. Instead, science is embedded in society as a matter of practice. Now, this is further made complicated by shifts in the understanding of societal responsibility. As I already mentioned, in the 20th century, scientific freedom was often construed in terms of freedom from responsibility, including in the AAIS 1975 report on scientific freedom responsibility. You think, aha, they finally discovered that freedom comes with responsibility. No, not in 1975. In that report, if you were doing basic science for basic researchers, there were no responsibilities for the implications or impacts of your work. Only for applied researchers did you have to think about that. And very often the institutional constraints of where you worked, such as working within industry or within government, then that helped you meet the responsibilities. Now, this view by the 21st century came to be seen as wholly inadequate. And I've written about this shift in greater depth. By 2010, we had pervasive concerns about dual-use research, research that could be used for malicious purposes. And initially, people tried to delimit what might turn into dual-use research by things like select agent lists. If you're working with these particular microbes, then you had dual-use implications. Within a few years, it became clear that there was no such list, that any area of science could come across a discovery that had dual use implications at any time. This was a pervasive part of scientific practice. And so the idea began to shift that scientists had to think about those implications. So on Being a Scientist report from 2009, the third edition of this report, they finally said something like this: the standards of science extend beyond responsibilities that are internal to the scientific community, like don't commit fraud. Researchers also have a responsibility to reflect on how their work and the knowledge they are generating might be used in the broader society. Right? So just think about how your work might be used. That's in 2009. So that's only 15 years ago. That statement got stronger by the end of the 2010s. So AAAS issued a statement on scientific freedom and responsibility in 2017, where they argued that freedom only comes with responsibility, and that included responsibility for the impact of work on society. The World Economic Forum Young Scientist Code of Ethics has similar themes, and the International Science Council in 2021 issued a statement that included the idea that scientific freedom must come with social responsibility for scientists in all areas of research. So by now we have this very strong shift to you only get scientific freedom if you also bear social responsibility along with it. Now, this means that values are required in science. You can't have social responsibility without also incorporating the social and ethical values that shape the choices that one makes to do it responsibly with values. And in my own work and in other work by philosophers of science pictured here, we have articulated at least two. These aren't the only ones, but these are two crucial places for social and ethical values in the practice of science. The first is in the directing of efforts of scientists, such as framing problems. And your previous panelist, Iona, talked about this in her own research. So are the right range of hypotheses and evidence being considered to capture the phenomena and the problems that might be at stake? And is the framing of the problem good? Is it the way in which the problem should be framed? And then secondly, when you have already framed the problem and have collected evidence, is the evidence strong enough to support a particular claim coming out? What counts as sufficient evidence? How much uncertainty are we willing to accept? And which errors are most important to avoid, false positives or false negatives? If you think about the debate in climate science about whether or not sufficient attention is paid to the tails of climate modeling and those extreme possibilities, this is a debate about the potential uncertainty embedded in those things and the potential implications of error of not paying attention to those tails. So additional places in scientific practice include in the methods one uses as a scientist, the modeling decisions that you use, and of course use decisions. So if you want to look at a full range of these kinds of things, Kevin Elliott's book, A Tapestry of Values, An Introduction to Values in Science, goes through a lot of the different choices that scientists must make that require values in science. And Matthew Brown's recent book, Science and Moral Imagination, talks about how to think about the relationship between values and science as we go forward in the 21st century. So what does this mean for the practice of doing science? The pure aloof scientist is no longer a good ideal. Right? If doing science comes with social responsibility, as these statements by all these esteemed international organizations say, then we require scientists to be more than just aloof and outside. And we see this in the way in which scientific organizations increasingly have awards for things like speaking out in public engagement, public communication. This is increasingly something that's rewarded explicitly by scientific organizations. Further, we have large-scale funding projects for doing research for the good of humanity, that is also increasingly rewarded, like the Horizon 2020 grant cycle. So the socially responsible scientist is a much better ideal given the current context we're in. But we haven't really reworked all the details of the social contract in light of this change. And so the details are still in flux. And you might be feeling some of this pressure in your own experiences. So what are you actually responsible for? In my own work, I've argued that scientists aren't responsible for all the consequences and outcomes of their work, that it needs to be limited to at least what is plausibly foreseeable at the time they make the decision, because scientists are not more omniscient than anyone else. But that still creates sort of confusions about what you might be responsible for, and responsibility to whom, what kind of accountability structures we need to have in place or should have in place is a really open and contested question, and I am actually currently grappling with this very question. How should the sense of responsibility that I've articulated here be woven into practice? Most scholars have argued that checklists, like the kinds of going through and meeting minimum requirements, is wholly inadequate for the kind of responsibility we're talking here. Similarly, offloading to have someone else be doing the job creates problems of you need to turn over to them decision-making authority over the decisions that involve responsibility. And most scientists don't want to do that. That infringes on scientific autonomy. So maybe embedded assistance within research, or maybe more integration into the practice of science through research ethics advice, embedded ethicists. These are ongoing debates. What I'm going to focus on here today is whether or not pervasive senses of social responsibility risk politicizing science. And this gets at the core questions of whether or not advocacy or activism is acceptable, and how to combine the demands, the call for social action, and the demands of scientific inquiry in practice. Ultimately, we're going to be talking about the need for a new science-society relationship, or a new social contract, understanding science as embedded within the messy, complex society we all live in, but as not being the same thing as identical with society. And so if we think of science as sort of its own special sphere, but with a permeable membrane around it in society, kind of like the nucleus of a cell, what norms should govern the permeability of the membrane around science? What should pass through that membrane readily, under what conditions, and what needs to be kept out to preserve scientific integrity? What are the essential structures for the pursuit of science that need to be protected? So if we understand science as taking place within society and dependent upon society for funding, for scientists, for new scientists like you who are in the midst of training, you came out of society, for problems and ideas that scientists want to pursue, and ultimately for the uptake of the ideas, if you're doing science for the good of humanity, humanity has to then embrace the science for that good to come to fruition. If there is this kind of strong interdependency, and at the same time, science is a distinctive activity because of its epistemic aims, and because scientific communities follow distinctive norms, how should the demands of societal responsibility work with the demands of inquiry? Okay, and this gets us to the challenge of politicization. Okay, so the risks of politicization are real. Anyone who's been following climate science for the last 20 years knows this full well. But any influence on politics on science can't be viewed as politicization, because politics can legitimately influence science. Politics influences science legitimately through funding decisions, by sort of setting amounts of funding to go to science, by politicians explicitly endorsing and funding big science projects, by trying to incentivize scientists to pursue particular areas of research. Further, politics can legitimately limit scientific inquiry. They do so through human subject regulations, how we handle human subject research, biosafety regulations, what kinds of labs and requirements have to be met in order for you to work on particular kinds of organisms, animal subject regulations, open science requirements, restricting topics. Currently, there are international conventions against biological and chemical weapons research, and most of us think that's perfectly fine and not a politicization of science. And then there's national security issues that can arise with classified information and the imposition of export control on particular scientific research. And then finally, there's accepting and rejecting science advice. So a lot of times politicians, even when they respect science and understand science advice, might decide for overriding other moral, political concerns to set aside or reject certain pieces of science advice, and that is perfectly legitimate. At the same time, science can also deeply interfere with science in problematic ways. I mean, the classic example from the 20th century is, of course, Stalin and the Lysenko affair. That took place in a non-democratic state, so let's focus on cases from democratic states where it's sort of more interesting for our conceptual purposes. In my own work, I've looked at the role of Richard Nixon and his lying about science advice he received, and the way in which that played out in the US. George W. Bush interfered with the production of climate science reports, trying to alter language after it had been drafted. Harper made a mess of all kinds of public interest science efforts in Canada. So science was damaged in these cases, and we can legitimately say it's politicized. But what do we mean by that? So in my view, we should talk about politicization when we have an illegitimate influence of science on politics on science, not of science on politics, sorry. So, but when is a political influence on science legitimate or illegitimate? It can't be any political influence, because I just gave you a list of all kinds of legitimate political influences. It can't be when there are just political values involved, because we've already rejected the value-free ideal and said that their value is essential to the practice of science. And it can't be when the scientific community protests, because sometimes politics legitimately constrains the practice of science. When, for example, human subject oversight regulation was put in place in the US, a lot of scientists protested hugely that this was going to destroy science. But frankly, given the abuses they had been committing with human subjects, they needed to be reined in politically. So in this talk, I'm going to answer that politicization occurs when you ignore or damage the norms within the space of inquiry by replacing them with norms from politics, and particularly from democratic politics. When we go through the norms for the space of inquiry, we're going to see that some of them kind of sound like the norms for democratic politics, but they have distinctive, important differences. And it's when we override those differences with norms from general politics that we end up with the most perhaps egregious and important cases of politicization. This is against the backdrop that inquiry is not the same as politics, even within societal spaces. Okay, so let's talk about the space of inquiry. Oh, good. We're doing well on time. All right. So here are 4 norms that I think are distinctive for the space of inquiry. I don't want to say that these define the space of inquiry. That's a philosopher's thing to do. I want to just say that these are distinctive for the space of inquiry, and that they often look a little bit like political norms, but they're different. And that difference makes all the difference. The first is that there are clear and public boundaries for legitimate inquiry. So some things we've excluded outside the boundaries of legitimate inquiry, like deceiving human subjects into agreeing to medical experimentation. No. Or coercing them in some way. No. These restrictions are not themselves politicization, as long as the restrictions are clear, precise, and widely known. We get into trouble when boundaries around the space of inquiry blur or are fuzzy. That's where politicization occurs. The second norm is in criticism and response. Within the space of inquiry, every criticism needs a response by someone. Now, this is really challenging for all of us who are within the space of inquiry, because sometimes we actually want to get on with things and not have to deal with all the criticism. But it's really important that when criticisms are raised, that they are acknowledged and responded to. Now, not every criticism that's directed at a particular person, needs to be responded to by that person. Someone else could respond for them. And that's particularly important if you have really prominent members of your scientific society, then all they would do would be respond to criticism. And responses can be, for example, pointing to already existing work that have already responded to the heart of the criticism being made. So it's not like you have to generate a whole new response. But it has to be done, and done in sort of a timely way. Although time, you can always say, that's a really good point, and I need to think about it, and I'll get back to you. That's at least acknowledging the criticism, and hopefully you'll get back to it. This is a key difference with the space of politics, where not every criticism needs a response, far from it. Some criticisms don't even need to be acknowledged, they can just be ignored. And when you have someone who takes that norm of politics and brings it into inquiry and fails to engage with criticism and response, or merely makes a criticism, receives response, and goes back to the same criticism as if they didn't get a response, kind of a looping, that's when that person is an inquirer facade. They are pretending to do acts of inquiry, to participate in inquiry, and inserting inquirer facades into inquiry is a great way to politicize inquiry. The third distinctive norm for the space of inquiry is fostering diversity. It is extremely important for the robustness of scientific inquiry that diversities of experiences and perspectives are brought into the space of inquiry to raise all those criticisms and to provide new responses. So diversity needs to be something that's supported and fostered. The doors of science need to be more than just open, they have to be welcoming, except for those inquirer facades. As soon as you mark someone as an inquirer facade, all the marks of diversity are relevant. You can just ignore them. They're no longer practicing actual inquiry. And then the fourth is open-ended debate. Debate in inquiry should not be prematurely ended. And when it does close, it's usually on a consensual basis, that some kind of consensus has been reached, rather than a voting procedure as it happens in politics. Okay, so politics versus inquiry. Tacit boundaries of acceptable practices are actually quite legitimate and can even be helpful in politics to sort of, just have tacit agreements about what is and is not legitimate topics of debate. In inquiry, the boundaries of legitimacy need to be clear, known, and precise. In politics, criticisms do not require an acknowledgement or even responses. In inquiry, they do. In politics, you can actually have exclusive spaces. You can have, say, in the US, there's the Black Congressional Caucus, and only Black members can join, and that is totally legit and acceptable. It would not be acceptable in scientific inquiry to have an exclusive space like that. Not all exclusive spaces in politics are acceptable, like having, only white members of a party would be problematic. But that's about power differentials. So some exclusive spaces are perfectly acceptable in politics, not so in inquiry. In politics, debates can be closed with procedures like voting, even if people don't agree yet. But in inquiry, debate should not be closed until broad agreement is reached, or at least no one wants to continue raising objections. So politicization happens when we have the norms of politics imported into the norms of inquiry without recognizing that that's what's happening. So, for example, in the US, there have been this amendment made in 1996 that said no research funds should be put out by the CDC on gun control. And what that turned into was no funding of research by any federal agency on anything to do with anything related to gun violence. It went well beyond the boundaries of the original amendment, and that was a politicization. Something that Harper did as well, he also tried to sort of just intimidate scientists into stopping doing climate research, for example. Politicization through inquirer facades. If you think about the way in which people are funded to pretend to be active in inquiry, but to just do criticism response in that looping manner, the insertion of corrupt researchers into the space of inquiry also politicizes science. Politicization through exclusionary tactics, when Nazis banned Jewish scientists, when racism and sexism exclude members from scientific practice. That's a way to politicize science. Or to politicize science through premature closure of debate. Stalin and Lysenko, obviously when you send scientists to the gulag for disagreeing with you, that's a premature closure of debate. But also in democratic context, things like stacking advisory committees to make sure they get the answer you want is a way to politicize science. Okay, so what does this mean for practice for you as budding scientists. First, it means that being an activist scientist does not necessarily mean you have politicized science. This is the case because politicization occurs when the norms of inquiry are replaced with the norms of politics. So if you want to be a scientific advocate or activist, as long as you continue to respect the norms of inquiry, you can properly do so. So if you're engaging in criticism and response properly, even as an activist, if you're open to new evidence and to changing your views based on evidence and arguments, if you're not closing debate prematurely, even if it would be politically useful to do so, and if you're not automatically excluding challenging voices, except those problematic inquirer facades, you're perfectly fine being a scientist and an advocate or activist at the same time. So you can still respect inquiry and be engaged in politics. There's no necessary separation or demand for purity within the space of inquiry, just a demand to respect the norms of inquiry. For doing responsible science, this is where we're still, I think, struggling to figure out what constitutes responsible science in the 21st century fully. So I think it's, we're right now dealing with debates arguing about what the boundaries are for legitimate research. If you think about, for example, debates about whether or not people should be doing solar geoengineering research, how we should actually have that debate, and what kind of governance systems need to be in place to decide whether something is in or out of the space of legitimate research is really difficult and really fraught. And I think we're grappling with that sort of blindly at this point in time, struggling forward. This is partly because boundaries should keep as much as possible within the space of inquiry. We want that space to be as big as possible, because when we say that something is out of bounds, we're foreclosing the possibility of learning new things. And that's weighty, and we shouldn't take that lightly. But some things maybe need to be pushed outside the bounds of legitimate inquiry. So how should we have those discussions, and how should science govern that debate? We also need to develop much better support systems for scientists trying to do responsible science. I think there needs to be more pervasive research ethics advice systems, not oversight systems, not like human subject research approval systems, not like gatekeeping and checklists, but advice, genuine discussion and consultation and deliberation about what the right thing to do is. This should include a better discussion of ethics and science education pervasively through the development of one's training as a scientist, and more assistance with difficult cases, such as embedded ethicists who can sit with a scientist in a lab and help them think about what the right thing to do is in particular cases. Now, let me talk a little bit about the trust in science, the public trust in science. Because you might be worried, oh no, our previous panel mentioned all these situations where being overtly political, being open about the values in your research might actually undermine the trust that the public might have in your work. In my own view, and I don't have time to give that full talk here, I can give you a link to it online. Trust in science should be built upon 3 different components. One is a clear presence of expertise, which is displayed to the public by explaining the judgments that you've made as an expert to come to the views that you had, including the key evidence that's involved. That expertise should be developed against the backdrop of well-functioning scientific communities that are sufficiently diverse and critical to have the debates that you need. Remember those norms of inquiry we already talked about? And also shared values, shared social and ethical values. And that's because members of the public trust experts most, who would make judgments as they would if they had their expertise. We do this with medical doctors all the time. We trust the doctors who understand and will help us make judgments reflective of our particular values. For climate scientists, there's like climate scientists in the US who have found that being open about the values that they have including evangelical climate scientists, when they speak to evangelical communities about climate change. Displaying their values is a basis for trust in them as an expert. Now, you might be wondering, what about consensus? Is a consensus the source of trust in science? And consensus that is trustworthy is, of course, not just any consensus. It has to be a properly formed consensus from a diverse, well-functioning community that has had the debate it needs to have and had all of the criticism response from all the different perspectives. And then you form the consensus, right? That's the kind of consensus that's trustworthy. But notice, if that's the kind of consensus that's been formed, the shared values from a diverse range of the public will have already been included, and the concerns that those values generate will have already been addressed. So of course, that kind of consensus is exactly trustworthy by the broadest swath of the public, right? So that's the sense in which consensus is valuable and trustworthy. Note that all of this requires respecting the norms of inquiry, like criticism and response, and fostering diversity, and not prematurely closing debate, and that values are still central to those practices and to the trust in science that is generated. Okay, I think I'm doing okay for time. Yes, almost done. In conclusion, the space of inquiry, and scientific inquiry in particular, is not value-free, it's not responsibility-free, and it's not politics-free. Science is not independent from or separate from politics and society. It's embedded within society, a political space, and has pervasive responsibilities and values running through it. That doesn't mean that politics can't harm science. Science can still be harmed through politicization, because science is not the same as politics. And in particular, replacing the norms of inquiry with political norms is what damages science and politicizes science. This means that for you, as budding research scientists in practice, you should engage with criticism responses, unless you discover they're from an inquirer facade, and then you just need to flag them for your fellow inquirers that this is not to be paid attention to. You should be upfront about the values important to your work in framing, in evidential sufficiency, in modeling decisions, and share them with both your colleagues and members of the public, because that is a source of trust in your work. You should be clear about the key evidence for your views, because that's also really important for displaying your expertise. Be passionate and be honest about your work and why you're doing what you're doing. This means you can be an activist or an advocate and a good scientist at the same time. There's no inherent tension between the two, by respecting the distinctive norms of inquiry and pursuing the public good. Thank you.